Alright, my restream is not changing the title, but I think that's okay. This is OKC Sharp, so I'll have to change the title later, figure out how my restream is, why my restream is not working. So let me check this. Oh, I think it technically changed the title, and at least for the YouTube one. Let me see here. Alright, yeah, that looks good. Nice. Alright, well, I think an alert went out. I was planning for the alerts to not go out, just sort of do this one a little bit incognito in a way, just sort of do a fun little refactoring, not really telling anyone that it's happening. You know, if anyone's interested in joining or usually joins on their own, that's great. But if not, then no big deal. I will just mess around a little bit here. Okay, so between streams, you know, all that good stuff. In our last stream, we did a tic-tac-toe board, and there are some certain things that I was on the fence about. We did a really good job together, but then I came back and I did some refactoring. And today I want to maybe put some AI into the computer, perhaps. So what I did when I did some refactoring, I don't want to go into that too much, I sort of want to jump into some things. But one of the things I did is obviously added unit testing. I made this unit testing system where I can essentially duplicate what the board looks like. So this is just the board. This is the first spot, the middle spot, you know, the bottom right spot. I did a little bit of that. So in this one, I'm creating this board start as if the board starts with this. Then where would I go next? So starting with someone had gone here, where would O had gone or whatever? Or if someone had gone here, you know, obviously you'd want to go here in tic-tac-toe in order to stop them. And so I made all these board starts, every single possible iteration. And then I don't want to go into all this too much because I want to sort of get into the test-driven development of the computers, the computer trying to be a little bit smarter, trying to win instead of just trying to stop me from winning. So what I did is I just iterated through these board starts, these challenges to guard space, and made sure that the computer was finding spaces and blocking me wherever possible. And then the same thing with these win conditions, to make sure that, like, if you were in certain scenarios, winners. Okay, so this should be a winner. So I want to make sure that this is considered a win condition. I want to make sure that I'm not sure. I did this a couple days ago. So this should be a win condition. Obviously, this should be a win condition. Am I missing something up here? Winners. Not winners. Oh yeah, the not winners would be things that are not win conditions. So non-winners, obviously if the board's empty, or something like this where it's just not obviously winner. So I added some unit tests, put some unit tests in there, and refactored a couple things. I changed it from a dictionary. If you happen to be here last time, our board was, where is it? UI? Oh. Right grid. Okay, I changed everything from a dictionary of string to a list of character, and then I just used the indexes of the lists, flattened out the board into a list, and used that. Okay, so I'm going to try to add some space, some intelligence to the board a little bit, and and see if the board can actually try to win me instead of just trying to defend against me. So that should be inside of the service. Make a move. Computer go. Okay. All right. Let's do a little bit of programming on the fly here. Yeah, Kimberly. I mentioned that in the beginning. My restream usually does it for me, but my restream is broken, so I'm gonna have to jump in there afterwards and change the title, or definitely change it whenever we upload it to YouTube. My restream just stopped working, which I had hoped it would just keep working, but it logged me out or something like that. Okay, so right now we've got computer go, it's being referenced mainly in this one place whenever make a move happens. So it's usually the player's turn and then the computer goes, whatever the case is. But we also have it referenced in 3 unit tests. These are the computer go tests. So what I'm going to do is try to come up with something else. And I hadn't put any thought into this prior to this. Just got back from a little bit of vacation, so just doing a little bit of freestyle programming here. So I'm going to make a new fact here. I'm going to say computer go, something like tries to win. Computer tries to win. I'm going to make it a little bit more specific than this, but I want to say that one scenario is if it is let's do it like this. I don't like that auto does that. So if it's blank X. Yeah, there we go. And then it's X blank O, and then blank blank blank. So right now, the way that it's programmed, if you were here last time, you'll know, it just chooses the first space. As long as it's not trying to defend against me winning, in which case the X has no way of winning here. But if the computer's O, the next blank space will end up being this, and so that's what it'll currently do. Now, going here, of course, they won't win, or going anywhere else, they won't win. But at least in trying to win, this should be their next space, or maybe they're going to try to go down here to make a 3 in a row. I don't know. It's not going to be a super smart AI, probably. But it shouldn't go here, because there's no chance of winning if the computer goes here. So I'm going to write this test to say, given this board state, they shouldn't go here. Maybe I should make it more decisive of a possible win condition. Okay, this is going to end up being do something like that. Okay, so X has no chance of winning in this case, but O, given this win condition, won't just go in the next available space. It will try to go here. Okay, so let's try that, something like that. Save this, go up here. Challenge to guard space. Board starts. Let me just see how I did this before. There we go. Okay, so we're going to do O, null, X, X. Yeah, this is right. Null, null, null. We'll do X here, and we'll do O here. All right. Yep, that looks right. And then we will say all right, so the found space currently is going to come back as this one right here, I do believe. So 0, 1, found space equals 0, 1, 2, 3, 4. I want it to be 4. So we're going to say run. Step 1 in test-driven development is write a test that fails. Expected true, got back false. All right, let's do it that way. Give me a better message. All right, expected 4, got back 1. Oh yeah, 1, okay, because it's 0 base, of course. 0, 1, 2, 3, 4. Okay, got back 1. So it got back what I expected it to get back from how it's currently programmed, but now I need to program it so that all other tests pass. I want all the other tests to keep passing exactly as they were, but in this instance, I want it to try to win. And actually, some other tests, certain scenarios might end up failing, because when it gets smarter, if I'm just saying, oh, well, I'm just expecting the next one to be filled in, if I have any tests like that, those might end up failing as well. But let's just go ahead and make this one try to pass. So, okay, so I'll make a copy of I'm making a copy of the board here, and that's so that I can iteratively try to find places that I can go and mess with the board and see if the win condition is met for that board without actually altering this set of tiles that comes in, whatever the case is. So I'm making that copy there. Null tiles equals, so these are null tiles. So these are the places where the board, where the computer can go. And it just gets a set of null tiles. So it selects the index of if you do a select, a lot of people use link and they put just an X or a single variable name in here. But if you put 2 input parameters, then the first one ends up being the value, and the second one ends up being the index inside of the collection. So in this collection, I've got the index coming in here so that I can create this collection that has what the index is and what the value is, but where the value equals null. So what I actually end up getting back is this collection of index and value. The value is going to be null because I specify that here. So these are places that I can play, and I've got the index. So if offensive play equals null, which it's going to start off as null, then offensive play equals tile.index. So I'm going to try, this is where it does whatever their first one that it finds is going to usually be what it ends up being. So copy tile.index equals player. Oh yeah, this is another thing I did is I specify these as constants in my refactoring. So the player's an X and the computer's an O, and that is actually good to know. Yeah, computer's O. Okay, that's exactly what I wanted to happen. Okay, so so we're going to assume that the player. Okay, so what this is doing is saying, okay, we're going to have the player go somewhere and see if that means that the player wins. And then the goal of that is if the player ends up winning, then that's the place where we want to go, because we want to make sure that, well, we being the computer in this case now, because we're going from the computer's perspective. So if we stick the player inside of that null space, and then that ends up being a win condition for the player, then we want to go there as the computer. So okay, and so that just loops through until it tries to find a place and either returns that we definitely want to go there, or if it ends up dropping out of this and if offensive play does not equal null, so an offensive place of, okay, yeah, we can go there. And this just says if it's the very first one that we find, so the very first time that we come through here where this is null, we're going to assign that, so we just want to go there. So if it does not equal null, which it shouldn't, then go ahead and do this. Okay, so I'm just catching myself up a little bit here. So if offensive play equals null, then just do this. So we want to get rid of this, I think, essentially. So instead of saying just get the first null one, we want to say, I think, keep doing what it's been doing, where it tries to, if it finds a win condition, then to return it. And then if not, then it resets it to null, and then it comes back around and does that over and over again. But then if it gets through this, I want to make a better offensive play down here. So let me see, turn 4. I know that's not quite right for what we're doing, but let's just see if that makes us pass. Ooh. Another thing that I did is I turned on treat warnings as errors. So that should have just been a warning that I'm not using that, but I have treat warnings as errors. So temporarily I'll comment that out, and I will say run this test. Hey, it passes. It equals 4. Perfect. Okay. Of course we don't want to keep it like that. I just want to make sure that that looks good. Go for the win first. Obviously go for the win first. Thanks, Brett. That makes so much more sense. Okay. I'm still thinking defensively. Yeah, definitely go for the win first. Okay, so offensive play equals null. So I guess this would actually be defensive. No, because defensive play would be this. So maybe I just get rid of this, and then here, this is where I'm going to try to do my offensive play. And if it doesn't do the offensive play, it'll do this. And if it ends up dropping out of this, there's no offensive play. There's no defensive play. Then what are we doing here? Okay, cool. So I'm going to say I still want the null tiles as something that I'm going to be using, because of course I need to know the places that I can go. Yeah, okay. So first do for each our tile and null tiles. I'm going to say, maybe I should make another method that says if computer win condition met. Then I got to go through all these things again. But I do need to determine that, don't I? Or I can call it if lose condition met, because all of these methods are currently from the perspective of the player. So if lose condition met. Don't I already have something like that? If win condition met, check row. Oh, I didn't make this specific to what I'm just saying a win condition was met. So as long as my computer go is, instead of putting the player, if it's trying to stick the computer in there, then the win condition will be met because it was met. I'll just have to know by context that since I was sticking the computer in there, the win condition was met by the computer. Okay, cool. So maybe I can even reuse this. No, I like the idea of going through all the tiles first to see if there's a win condition, not reusing this. So let's keep it as two different loops. So I'll do this as computer, and then if win condition met, return. I mean, is it going to be this simple? Is this going to be the whole thing? Let's just hit run. I'm just curious if this ends up. Oh, look at that. Easy. The computer is now smarter. It tries to actually win. Yeah, that was really good. Thanks, Brett. Let's see if I broke any other tests, though. Yes, I ended up breaking this one. So I think this one's just trying to make sure that it just goes to the next space. So finds a space, found space. Ooh, is it just not finding a space for one of the specific theories? Why did the computer go if there was nowhere to go? Which one is failing? So number 2 is failing, and number 1 is failing. Number 1 and number 2 are failing. For board starts, well, there should have been somewhere to go here. So something's broken now that it's not just selecting whatever the first one it finds. Because right now I'm only selecting that if there's a win space. So I took out the part of just go offensively. Let's go ahead and put that just go offensively thing back in there. And yeah, because here it'll find somewhere to win. Here it does win, so everything ends up being, yeah, okay. Let's just put the go offensively thing back in there so that our tests pass. And then we'll come back in here, and instead of just doing a win condition, go for the win, we'll say try to make somewhere smart. Try to pick somewhere that's smart to go. So computer go. So it doesn't find somewhere to win, and so I can do this, I'm going to do this offensive thing again. Tic-tac-toe service. Offensive play, and then stick this back in there. Bam, and then all right, well, we got a dumb offense going in there. Awesome. All right, so that was pretty quick. Yeah, we made him go for the win, and then now we're going to say, go for the win. If you can't go for the win, then be defensive. Yeah, then definitely be defensive. And then say, yeah, I'm going to obviously change this offensive play. I just wanted to get my test to pass again. But then I'm going to say, okay, I don't need to be, I can't win. There's no need to be defensive. So return be smart. We'll use the same signature as this. So we'll pass in, instead of the tiles, we'll pass in the copy. Hold on. What would be the most efficient way to do this? Yeah, we'll pass in the copy and the null tiles. Yeah. Why is it not like this? Null tiles. Can't convert from list. Well, why did it do that? Oh, okay, because it's a generic type. I have an inline type here. Okay, so tile. Yeah, I'm only using the indexes anyway. So tiles dot select x dot index to list. There we go. So now generate it. This will be null indexes. I'll just call this tiles, even though what we're passing in is the copy of the tiles. Okay, tiles, null indexes. Now we're going to be smart. I could even extract these into their own certain places also. I'll wait to do that right now until later. Okay, so be smart would be well, I got the test to pass with this stuff, so I'm gonna take it back out now. I just wanted to make sure that is what the issue was that was going into the problem. So now be smart is going to say we have these tiles, we have these null indexes. What did I just do? Am I being crazy? Return null indexes dot first. There we go. So now the test should still pass because it'll just give me back the first null index. Oh, I had one in here that was expecting that exception if the board really was full. Well, if the board really is full in that case, then this would be... Oh, it's probably getting an exception that there is no first, is what it is. Yeah, sequence contains no elements is what it's actually getting. If this dot count equals 0. Damn, easy. It's like science. All right, cool. Okay, so now we're back. We've gotten rid of the junk that was in there. So let's go ahead and minimize this, and we've got the be smart computer offensive play, and this will I should actually be able to test this itself. Directly test this, pass in the tiles of the board, the state of the board, and which ones are null. And then this should work perfectly fine. Yeah, so I'll just directly test this one, starting from right now. So go back over here. Computer tries to win. So computer tries to win is they have a space that they can go to win. So that's great for them. But now I'm going to do this other one where computer offensive play, you pass on the board, and I hate to redo link. I think when it comes to over architecting or trying to do too much up front, I think that it's safe to say that we can not pass in the null indexes here and instead redo this link right here, which I wouldn't say that, right? This is definitely a place where we'd come back and possibly add make it faster later on. But for now, for simplicity of testing and just getting our stuff done, I think this is perfect. Actually, this brings up another good point. Just select the index because we were only using that the value in order to do this where clause. So I'm gonna simplify that down to that, and then of course rerun my tests. Oh. Computer goes offensive. I can rename that again later on. Oh, this one's probably not going to pass. Perfect. All right, so computer goes offensive. So the board state that I'm going to look for, if we were talking about, let's just start null. Let's assume that the computer goes first, which they don't currently in our scenarios, but I think this is a good starting scenario. Whenever you go first, I think the best place to go is a corner place. So computer starts offensive, and so for now we're going to say start here, and then found space should be 0. Computer offensive play. Yeah, let's do that. So computer offensive play. You know what? It's true. I'm going to go back on what I said. It's just true. We don't currently have it programmed to say if the computer goes first, because they're not going to go first. I don't ever plan to make them go first. So I'm going to say that the player goes here. So if the player goes here first, then the best place for the computer to go will definitely be the middle. Something like that. And then we have to just make it say if the computer, if the only place that the player has gone has been in a corner, then go middle. Yeah, we'll go ahead and do that right now. So found space should be 0, 1, 2, 3, 4. All right, yeah, I should have already known that. Should be 4. And this should be a theory, something like this. I'm going to go ahead and make up these different boards with the X in the different corner spaces. Player started with corner. Yeah, player started with corner. I'll just take one of these. Player started with corner. All right. No. I don't need this. Okay. 1, 2, null, x, null, wrong one. This one, x, this one, x. All right, so for all of these instances, the computer should bam. There we go. So for all those instances, the computer should go in space number 4. Of course, it's not going to, but let's go ahead and run it. Okay, got a failing test, and now we're going to come in here and make it work. And that's all going to be, instead of returning first, we're going to say go here. Oh, popping my knuckles here. It's a little bit cold. Okay, so how are we going to do this? Here we go. If null indexes dot count, is this a list or an interval? Count equals 8. Then if let me see here. Cool. All right. So if there's 8, which means that there's only been one space that the player has gone, then if let me see here. How would we determine the space? Okay, so if tiles 0 equals player. 0, 2, 0, 1, 2, 3, 4, 5, 6, and 8. Oh, whoops, list of int. So these are the positions that are corners. So if corners dot any tiles x equals player. Okay, so if any of these, and so this is going to end up being that index. So if we check the tiles board and that space for that index 0, 2, 6, or 8 equals player, then I'm missing one of these. Then let's just do single line return 4. Bam. Ha ha ha. Very nice. Okay, so we're saying if we were playing the game and we saw someone went corner, we would definitely want to go middle, because at the corner they have 3 spaces, 3 directions that they can win, that they're moving into, and if we block off this one, that blocks off one of the directions, but also it stops them in the future from trying to get any sort of any other direction. If you were to go here or here to try to block them, then they still have 2 spaces, but also they're open to you're open to more vulnerability later on. So you need to be super defensive if somebody goes in the corner to start with. Okay, so we've got that down. So computer starts offensive. Player started with corner. Computer starts offensive. All right, very nice. So if we were to say that So count does not equal 8. If count equals 8, okay. So what if the count equals 8, but they did not go to in a corner? They went in. I mean, typically the other space they're going to go is the middle. So let's go ahead and address that as a possibility. Player started with middle. That's only a single thing, so I'm just going to have that in here. Computer starts offensive. Actually, defensive. This one's this one is defensive, so I'm going to go ahead and keep that. I'm going to rename that as defensive, because even though we're getting into the offensive section and the computer is going to try to be offensive, what it is deciding is to be defensive against a corner play. So I'm going to name this computer starts defensive, but this one for computer starts offensive is going to be if the player does start in the middle. So let's do null. So if the player does start in the middle, then the computer is going to want to go in a corner. And maybe in the future we can randomize it, make the computer choose a random corner, because it's, you know, a tic-tac-toe board is exactly the same as if you just rotate the board around. It ends up being only a couple different options. Let's say that the computer ends up choosing, for now, they'll just end up choosing space number 0. Oh, because this is a theory. It should be a fact now, because there's only one input scenario. And so we're still in this situation where there's 8, but they did not go into the corner. So if they did not go into the corner, even, if tiles 4 equals player, and return 0. So I just thought about this. We have this, the computer's being offensive. If they do go into an edge, we wouldn't, like this edge right here, we wouldn't want to choose this corner, I don't think. I think we'd want to choose this corner right here. Or this one, like this one or this one, if they went to this edge. So it's not going to be exactly the same every time. So we've got, if they go in the center, the corner really doesn't matter, so we'll just choose corner number 1. Okay, and then we're going to get into the else section down here. So if they choose, for now let's just hard code it. If tiles 1 equals player, then return 6. That's if tile 1 or 1, 0, 1, 2, 3, 4, 5. 5. Tiles 1 or tiles 5. Then we'll choose 6. And then otherwise, return 2. Sort of got ahead of myself a little bit there. I need to put those edge cases inside here. That's not test-driven development. Player chooses middle. Computer chooses corner. Player chooses edge. Computer chooses opposing corner. I could be mixing up my logic also. Maybe opposing corner is not the best thing to do when the first player chooses an edge. But let's go ahead and do this same type of thing right here, actually. But player started with edge is what we'll do here. that space down. Okay, so player started with edge, so we're going to say they went null 4 times. They'll go here, 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 here. Southwest. Southwest. Okay, so we have 2 different scenarios for 2 different outcomes, and we're going to say player chooses northeast edge. Okay, and in that case, we were choosing 6. 6. Then we will say we're choosing 2, was it? What have I done? Okay, so if they go middle, then computer offensive play. If they go middle as their only thing, let me see here. If the player goes in the corner, if the player goes in the middle, return 0. Tiles 4 equals player, return 0. Tiles 4 equals player. Oh, did I get that wrong? My test. Oh. Player's X. Tiles 1 equals player. I've been doing X's this whole time. I don't know why I put an O there. Or why it passed previously. There we go. Alright. Alright, cool. I don't need to make this a full-on hour-long talk. I'm going to go ahead and check this in. Add some intelligence to the computer. And we're saying if it gets past whatever our logic is, we can definitely be adding a lot more logic. If we get past that logic, then we're going to just return whatever the first is. That's why the other tests continue to pass for that. All right, let's go ahead and play it. I mean, heck, we got the unit tests going down. So I'm going to go 1. Yep, computer blocked me off at 0. So, of course, now, being as defensive as they are, if I go 2, they're going to go 3. And then I'm going to have to go 7. Now I have to play defensive. And then I have to go 6. And then 9. Of course, no one wins. I should have zoomed that in. Let's go ahead and play it one more time and try something a little bit more. I'm definitely not going to win going in a corner. So let's try 5. And then let's try 2. and then 3, 4. I suck. Oh, it went on the bottom. See me trying to play offensively, forgetting the computer can actually win these days. Let's do it again. I don't mind. I don't mind. Okay, 5. And then we will go 3, 4. I guess 8. We did our best. All right, cool. I like it. Well, I'm going to go ahead and jump off here, and thanks for anyone who showed up or anyone who watches this in the future. I just wanted to have a fun little freestyle programming session going on here, and may need some renaming of a couple things. I'm going ahead and actually I'll put this in the master branch, and you guys can see what changed during my refactor. Mainly changing from a dictionary to a list of character for stating the state of the board. That's the main thing that I went ahead and changed, and adding tests. So I'm going to go ahead and check this all in. It is committed to the refactored branch at the moment, and I hope to see you guys next time. Thanks.